Good morning, everyone. Thank you for coming here. My name is Yogi. I'm a 8-year-old racker. I'm working for GET. There are many terms in humanity or in physical world, when applied to technology, they start providing meaningful insight. Technical debt is one such term. Today, I'm going to introduce what a technical debt is, and then spend some time talking about how we could track and manage technical debt, and eventually I'm going to conclude with some key takeaways which we could take from this presentation. So, I'm sure many of you here are familiar with debt. How many of you here have incurred one kind of debt or other? Okay. We all incur debt, right? It's fact of life. A debt allows you to accomplish something that you couldn't otherwise accomplish. Imagine buying a house or a car and you want to save some money to buy a house or a car. It's going to take years for you to get it done. So a debt is bit and parcels of life. The most common kind of debt we all are familiar is the financial debt. So usually you have some institutions lending you money. You pay this money with some sort of interest. A formal definition of debt is something that's owed by one person to other person. So though debt is not essentially harmful, there is concept of good debt and there is a concept of bad debt. A good debt is something that adds value. Things like buying a house or getting yourself education is considered to be good debt because it increases in its value over a period of time. A bad debt is something that's decremental in nature. It loses its value over a period of time. So things like getting into credit card loans because you want to splurge on a vacation, these things are essentially considered to be a bad debt. So it's important to understand how debt plays a major role, and debt is not essentially bad. So just similar to the concept of financial debt, we have technical debt. The term technical debt was coined by Wirt Cunningham in the year 1992. Wirt Cunningham is a technology guy like us. He was the first founders of the first wiki. So way back, he was working on a financial software. So that time he was working with a bunch of folks with a lot of experience in the finance industry. So that time he was finding it very hard to explain them some of the problems he had in a term that the financial people could understand. So he was building a software called Ycash Financial System. So that's when this idea of debt metaphor struck on his mind, and he started using the term technical debt, and they were able to better relate, understand his software problems, and better appreciate. So here is a formal...
Can I just interrupt you just 1 second? You're like the first person who's actually held the microphone correctly.
Oh.
But because nobody else does it,
okay.
You have to hold it a little bit further,
okay.
Like 1 inch further, not much.
Okay, awesome.
Because it's super loud back there.
Okay. Is it better now? Yeah. Okay, thank you.
The first person to do it right.
So here is a formal definition of technical debt that he gave.
Perfect.
Any term or approach that is expedient in the short term, but turns out to be complex and brings in more work in the long term is considered to be a technical debt. If you take any organization, it's impossible not to occur technical debt. Every organization would incur one sort of technical debt or other sort of technical debt, but if the debt is not managed, it could lead to serious consequences. As a software developers, every time we build a software or we add some new functionality, we have two choices. Always we have an easy and dirty way in which we could get things done. We also have the correct way of doing things done, which most of the times takes more time. Sometimes due to a variety of reasons, we choose the easy and dirty way. There are so many other reasons why we want to do that, and that's what is technical debt is. The easy way, even though it allows you to achieve something in the short term, over a period of time, it starts bringing in more work. That additional work that you're incurring because of the quick and dirty way that you took, that additional work is considered to be the interest that you pay for technical debt. So as an organization, there is going to be a lot of legacy software. An organization is always going to build new software. So we are always going to incur technical debt. So it's important to measure and track and understand what a technical debt is so that we are always aware about the problems, the issues around it. So now that we have seen what a financial debt and what a technical debt is, I'm going to take some time explaining what are the similarities and differences between them. Just like a financial debt, a technical debt also incurs an interest. The interest comes in the term of additional work that you're asked to do. But however, the choice is, unlike a financial debt where you don't have a choice whether you're going to pay your financial debt or not. When it comes to technical debt, you have certain choices. You could delay paying your interest. You can not pay your interest. Those kind of choices are not available on a financial debt. So just similar to financial debt, a technical debt, if it is unmanaged, it could lead to major issues. So it's important to manage the technical debt in a right fashion. When it comes to financial debt, you get different statements, kind of different metrics from different financial institutions, which clearly tells you how deep you are into financial debt. But when it comes to technical debt, you don't really have any tool that's going to tell you how deep you are in. To a large extent, it's the discipline of the organization, and it's a bunch of assumptions and bunch of coordination between the teams that's going to really educate the organization on how much technical debt they're incurring. So this is something called as technical debt quadrant. This was proposed by Martin Fowler. I'm sure many of you would have been familiar with him. So the idea was like he was trying to categorize technical debt into different kind of quadrants. If you see the last one, prudent is something that you're well thought through, you're thinking about the future. Reckless is you're completely careless, you're not thinking about the future. And again, deliberate and inadvertent, as the name implies, deliberate is you're purposefully doing, inadvertent is you're accidentally doing it. So the kind of technical debt he says an organization should really incur is the debt that fits into prudent, deliberate quadrant. That's a quadrant where we have really thought about the problem, we know what the consequences are, but still we are making a well thought through decision to incur a technical debt, but we're also thinking on how we could deal with the consequences in the future. So that's the kind of technical debt he's encouraging us. But if you see reckless debt is something where people are completely careless. They're just worried about what they need to do. They say, I don't have time for any future design. That's an example for reckless debt. And inadvertent is usually it happens when you have a team which is not really knowledgeable. They don't have the skill set, so they make certain choices and decisions which leads to inadvertent technical debt. The last quadrant, inadvertent but prudent, that's interesting. So despite having a team which is very strong, which is well thinking through the problem, there are cases you could incur a technical debt because of your knowledge of the domain or of your understanding of the problem at that point of time. So despite being prudent, it's kind of an organization would incur some sort of a technical debt. So of all these quadrants, what many of them are suggesting is what we should really strive for is the last two, the prudent, deliberate ones, and probably even if we try, we couldn't prevent the prudent, inadvertent ones. So being reckless and inadvertent are not really recommended. So here are some examples of technical debt. So I've categorized things into debt related to code and testing and technical debt related to design. So it's mainly like skipping on coding standards, lack of automation, lack of coverage, not applying best principles and practices that are followed in the industry, wrong selection of tools, framework, lack of focus towards quality. These are all some examples for code and testing. And for design, lack of architecture, making wrong design choices, lack of process, lack of future thinking, all of these could be termed as a technical debt. So in an organization, an accumulation of defects, an accumulation of bad coding practices, accumulation of bad design and bad architectural decisions that are made, I would term that, all of that as a technical debt. So technical debt sounds all bad, but what makes an organization take a technical debt? Because many of them, they employ very smart guys just like we do. And what is it that really tempts people to take technical debt? So these are some reasons. So with the new concepts like lean startup, organizations are geared towards building minimum viable product, minimum learnable product. So the idea is to bring the product as early to the customer and start learning around the start validating some of the assumptions they have made around building the product. So many of the startups, they're taking this approach, and when they take this approach, at times they take certain shortcuts when it comes to technical decision, because the goal is to initiate the customer learning, not to build the perfect software, and they incur technical debt. So preserve cost. There could be organizations which would consider certain projects which are not really worthy, or they might be running out of money. So they might choose not to invest too much. They might hire people who are not really that great, and that could lead to technical debt. The third one is like crunch mode. So this happens in many times in many organizations. You have someone from the top dictating a date, and everybody scrambles to meet the date. They start cutting around corners. They take deliberate decisions to cut on the right design, right architecture, stop following right coding practices, because their only goal is to meet this date. That's an example of crunch mode. So, and the other one is like business pressure. So there could be organizations which are striving to release something early to the market just to be ahead of their competitor. So they might again end up chasing dates, and they might make a conscious decision to incur technical debt. So the last three are like incremental delivery. So with Agile and Scrum and these kind of technologies geared towards incremental delivery, just in order to accomplish this incremental delivery, at times you got to make certain design sacrifices. The aging software is what happens when you inherit a large piece of legacy code which has not been managed for a very long time, or your software which was written for very back is kind of left open and not maintained properly. The software has become old. A lot of new things have happened in the technology. So all of these old things need to be fixed. That's an example of technical debt. And the last thing is like growth of software. When you start building a software, you might think that you're building a software for a specific need, but as it evolves over a period of time, the original intent for which the software was built, it could be superseded by many different goals, and the original design which led to your thinking, the original ideas, they were all completely changed, and you have to revisit and change your software. So now that we have seen the many reasons why an organization incur a technical debt, who exactly is impacted by a technical debt? So if you see, an individual could get impacted, because if you work in a software team and you're constantly reworking on rewriting your software, that really doesn't make you happy. A team could be impacted. In case we have a team that has incurred a lot of technical debt, the ability of the team to produce meaningful software is largely compromised. They end up more time firefighting, and the team would really lose its value. A team gets impacted. So eventually a business gets impacted, because the ability of a business to produce meaningful business outcome is largely compromised over a period of time, as many teams within the organization, they're just in a firefighting mode. So the business itself could get impacted. So this is why for sometimes you see small startups challenging a big organization, because the big organizations are caught up with the legacy of technical debt they have incurred. These small organizations which are very new to the market, which don't have any bad debt, they could do things better despite having less manpower. So if you see the graph that I have listed on the left side, the graph tells how much people are aware about the technical debt. So the right quadrant is the technical teams who are highly technical. They're very much aware about the technical debt. On the extreme left is the business management. Usually their awareness about technical debt is largely less, and that's the reason why when you have teams which want to do certain cleanup or do things better, they really don't get a business buy-in, because the business really don't understand the concept of technical debt, and that's why it's important to talk the technical debt in terms of a language that a business could understand. So we saw many reasons why an organization could incur a technical debt. So if you think why an organization should not incur a technical debt, the biggest reason is not to get into a vicious debt cycle. So this happens when an organization really makes certain compromises on the design, compromises on the code, compromises on doing things in a quality way, and eventually they're taking shortcuts, and these shortcuts eventually lead the teams to just firefighting, fixing things that they have already done, and over a period of time, lot of things that are built on a bad foundation, it leads to organization spending more and more time trying to fix things, and it delays the delivery. This is the most difficult debt cycle that you could get into by incurring lot of technical debt without repaying it. So how many of you know what this picture is?
Mars rover.
Yes. So awesome. So this is a Curiosity rover. This was launched by NASA in the year 2012. So we all know that this is a very successful mission program, but there's a story behind this program. So the original date for this program was as early as 2009. So the NASA had a big software that's controlling many different aspects of rover. This project was again a multi-billion-dollar project. So the whole software of NASA was based on the initial version of the software that NASA had built when they were poorly funded. So they were very close to getting into the delivery date, and what they were noticing was their ability to add more and more functionality on top of this legacy software was getting largely reduced. They were seeing unforeseen problems, they were seeing a lot of issues. So they had two choices. A choice was to stick with the original date and release the software as early as 2009, faced with the consequences, or completely rewrite the software. So the NASA team took the second approach. They did not want to risk the software because a setback like this would cause huge public cry, because a lot of public money would have gone waste and would put NASA back in terms of years when it comes to research, as it would become hard to get funding. So NASA completely threw away the original software, but held the team that wrote the software, kind of took the concepts around the software, rebuilt the software right from the scratch, applying many different best practices. So by doing so, they were not able to meet the dates, but they were able to successfully launch the rover. So the rover is now successfully able to kind of send many details about the Mars, and they're now funded to get future explorations like this across the solar system. So this is one example how when an unmanaged technical debt goes out of control, the ability of the team is no more there to produce meaningful outcome, but they are left with a choice of throwing away the software. So how do we identify technical debt, right? So these are many different ways. One of them is smells. So you have members of the team complaining that I hate working with this software, and you have other groups complaining that this group is so slow. These are all different smells that the ability of the team is greatly compromised because of technical debt. So velocity decreases. So as we all aware, in agile world, we start measuring teams' effectiveness in terms of velocity. The velocity over a period starts decreasing because any work takes more time to do. As I said earlier, there is aging software. So there are certain tools to kind of measure certain kind of technical debt. For example, coding violations, coding test coverage, code coverage. These kind of tools could help to some extent. And the worst problem to face is the frequent issues in production. A poorly written software, a poorly understood software would eventually lead to a lot of defects in the production systems. So just I have been explaining, here is a graph that shows the ability of an organization to produce business value. As you all see, the more the technical debt increases, the ability of an organization to produce meaningful business value, it's largely begins to decreasing. So how do we manage technical debt? So this is a challenge that we face regularly within Rackspace. The challenge is even more bigger because no more we are working as one team. So we are spread across many different groups. We are spread across many different teams. Our challenges are across the team when it comes to making certain design decisions. So there are certain teams which individually manage their technical debt related to their teams. But when it comes to cross-organization technical debt, it's getting very, very difficult. So I have Ben here from my team. So we had a conversation about the technical debt that we were having, and he kind of suggested me to present this so that we could raise some awareness about the technical debt. So here are some of the concepts to kind of managing technical debt. So have a backlog of technical debt. Just like there is a business backlog, just like product backlog, kind of have a backlog of technical debt and explain the technical debt to the teams in a way the teams could, the business in a way the business could understand. So it's important for us as technical guys to educate the business about the technical debt in terms of the business value that they would get by getting this technical debt resolved. So the more we get collaboration from business and the more we talk the business language, it would be easy for us to get a buy-in from the business so that we could start prioritizing some of the stories related to technical debt. So some teams, they take this approach. They have the concept of make-up stories. Always the manager secretly kind of decides a number like 30% of the stories that my team has got. They'll always try to finish some technical debt. And there is this scout rule, keep the place cleaner than what you originally got here. Some teams follow this approach. Any code that they touch, they always make it a habit to make the code cleaner than what it was originally intended. So they include this cost towards cleaning in the very cost for the estimation. So again, these are the other concepts like having a buffer tasks for refactoring and combining these tasks with business stories, and eventually having some cleanup releases, making the team get some time so that they could focus on some of the technical debts. The team might not produce business outcome in those specific sprints, but we got to convince the business that whatever we are doing is something that's good for the future, and focus on sprints that's geared towards solving some of these technical debts. So how do we prevent technical debt, right? So it's an interesting question. Should we always prevent is always a question to ask. Again, we got to get into the mode of decision making. So whenever we get a problem, we got to see what's the quick and easy way, what's the costly way, or what's the right way. We got to understand the cost of doing it in an easy way, the business outcome it's producing, the cost of doing it in a wrong way, and the interest we got to pay towards the future. So it's kind of, I would say that it's kind of wrong to say that you should never incur a technical debt, always do it the right way. At the same time, it's always wrong to take the easiest approach and doing it in the dirty fashion. So we got to consider many different inputs, many different costs, many different details about the outcome that we are supposed to produce, and make meaningful decisions. And again, with Agile and Scrum, these getting popular, people have an aversion towards architecture. So anytime you start mentioning the term architecture, people kind of think that an architecture is not needed. We are Agile, we are trying to do what is needed right now for the business. So an Agile never says don't do architecture. It's talking about not doing heavyweight architecture, always a lightweight architecture, and coming up with decisions that could help us in the future always helps us for the future. So the third thing is like culture shift. I'll talk in the next slide with more details, but as an organization, we should have a culture of encouraging people who do things in a right way and not in the quickest or shortest possible way. And last few things are like strong process. Having a process and early feedback is important. Let's say you're building a UI or you're building an API. Rather than building everything and then making an assumption about the use cases, involving the different teams ahead of time, getting their input into the decision making would largely help us avoid building technical debt. Collaborative designs and reviews. So any code that's built or any big design that's made, it's always very difficult for an individual to make the right choice. I always believe in teamwork. The power of a team always is better than the individual. So encourage reviews and encourage collaborative design, identify these debts ahead of time so that we could better manage them. So how many of you are aware about trustworthy computing that was brought in by Bill Gates as early as 2003? So 2003, there was a time when Microsoft was getting very bad at producing software. The software had frequent number of debts. There were a lot of security compromises. But the teams were geared towards building more and more features and was not really taking these defects or security compromises into a concern. So Microsoft, the Bill Gates, then the CEO of Microsoft, he sent a famous memo to all his employees. He said that we have to change our mindset towards releasing more and more features. As an organization, we have to make a decision on fixing these software issues, fixing these security issues. When it comes to a security issue or when it comes to bringing in a new feature, he said the team should focus more towards on bringing new features, and he said we should make computing something that's guaranteed and something that's trustworthy, just like basic services like electricity or water in a developed world. So this led Microsoft employees all over to start thinking in terms of building a software that's better, that's more secure and more stable. That's an example of a culture shift an organization could have towards resolving technical debt. So again, there are many, as I explained earlier, there are many choices when it comes to pay technical debt or not pay. So you can choose to pay the technical debt that amounts to you fixing the software, taking the right decision. There is a cost involved. Make sure that the business stakeholders are aware about the cost. This other approach is what many teams do. They do debt conversion. They do the debt, repay the debt in small chunks. They take a debt which is very costly. They move on to another technical debt which is not that costly, which is not bringing in too much work, or they take the debt and start fixing things in small chunks over a period of time. The last thing is like debt write-off, like the NASA rover example. It's an extreme case where you have accumulated so much debt that your software is no more meaningful and you completely throw away the software. That's a decision that involves VP, C-level executives, and many others. And last is like you don't have to really fix all of the technical debt. On occasions, you can just choose to just pay the interest. So here is, I'm going to conclude the presentation. Here are some key takeaways I think is important. So one is for the business folks. So it's important for business folks to understand why always working on random dates is not good for an organization, and why teams have to focus towards doing the things in a right fashion. So the ability of an organization or teams not to incur technical debt, it eventually allows the organization to produce better business outcome. So it's important for us as technical stakeholders to make business understand this. So that's one takeaway. And as far as our technical folks are concerned, what I would like to reiterate is it's important to realize that not all the times incurring a technical debt is bad. There are many factors that business takes into consideration. There is a business pressure. There is a reason why business wants to meet those dates. So it's important for us as a team to understand some of these business desire and then make logical decisions and not being very dogmatic or saying that we would never incur technical debt. Being pragmatic and making meaningful compromises is all about life. The same thing holds true for some of the technical decisions that we make as well. These are some of the many different references I was able to refer. Thanks a lot everyone for attending, and thanks a lot RacksIO for the opportunity. Thank you so much.
Thank you very much. We'll change our presenters, and we'll be back.